we're going to be looking into vertical projectile motion. What a fun topic. So, VT, VPM, vertical projectile motion. Uh, Something that, some of us or some of you guys have been, talking about, saying that, this is quite a difficult thing. It's hard to understand the graphs, it's hard to understand this and that. Um, and basically, what's not going to happen right now is that I'm not going to be explaining how to necessarily draw the graphs, right? But I'm going to be explaining how to interpret information from graphs and henceforth see how we would how that would actually supplement your knowledge of how to actually draw the graphs and how that would work out for the rest of us. So let's get into it. We have a question for us here waiting today. So you are given the information that a ball is dropped and it bounces a few times, right? So keyword dropped, right? So dropped, and it bounces a few times. And if you look at the graph, right? Maybe let me see these dashed lines. Let me make them a bit more, noticeable, right? The ones that are going down. There's a reason that I'm doing those ones only. I'll explain later. But normally, if you were to draw your graph and there was bouncing motion, you are not supposed to show this part in solid lines. You're supposed to show it in dashed lines. That I told you that I wasn't going to be explaining how to draw graphs because I just love you guys too much. But yeah, that is the situation. First question, how many bounces? So even in a situation like this, it's actually quite important for you to first identify the following. You have to first identify the direction that has been taken positive, right? And henceforth, knowing that you would be able to go about the situation of calculating the rest of this. So if something is being dropped, that means that the force of gravity is acting on it, and henceforth is going under the influence of gravitational acceleration. Um, and given that fact, that means that it's going to be increasing its velocity going downwards, right? And if you think about it, what here depicts increasing, right? What depicts increasing is this. This is increasing. You're going from 0 to 8. That's increasing. So if it's increasing and it's being dropped, that literally gives you a hint that this positive direction is actually downwards. Alright, so they took down as positive. Sorry about that. So given the fact that they took down as positive, and this means that this entire motion is it falling, right? And if it falls, it's going to reach the ground. So it reaches the ground at a v final of 8 meters per second, right? And then when that happens, it bounces. What shows bouncing motion? Well, what shows bouncing motion is those dashed lines that I just colored in blue, right? That's what shows bouncing motion. Now, not to get ahead of ourselves, what is bouncing? When you bounce, you move or you're pushed in in a direction that is opposite to the one that you were going, right? Bouncing is not, you going down and you staying there. That's not bouncing. Bouncing is this, right? So although here you're seeing two lines, there was only one bounce, right? Because you were only redirected once. So if you were to count how many times were you actually redirected, well, the times that you were redirected was the time that you actually obtained a new velocity, or you obtained a velocity in a different direction, right? So in that case, well, let's look at it. It reaches down, so this is down, this is down, this is down, this is down, right? But although that is down, how many bounces do we have? Well, if it's down, with what velocity does it actually leave the ground? It's gonna be leaving the ground using this velocity, right? And the action of leaving the ground is what we call bouncing. Henceforth, this is your first bounce, second bounce, third bounce, right? This one is not necessarily a bounce because why? It comes and sits, right? Um, to an extent that's what we would actually call it, and that it's coming to sit down. If it wasn't coming to sit, they would have just ended it at this, right? They would not have done this, right? So that is the situation that we have right now. So, right. So why are you seeing writing on the paper? Well, crazy thing is, I thought that it was actually a recording when I was writing all of this, but it wasn't. So it cut halfway through, sadly. Um, but given time constraints, I can't really make another paper and write everything down. So all I'll do that right now is explain. So, considering what happened, we did classify that bouncing only occurs if there is a change in direction, and the change in direction is going to be, if it was initially going downwards, now it's going to go upwards, and that's bouncing, and you change direction by having a change in velocity, um, and henceforth, the place where you experience that kind of, motion is towards these portions. Henceforth, these are the places where you're going to be having your three bounces. Now, um, I believe I had explained that this is where you're going to be finding your positive section, this is your negative section, and your bouncing, not your bouncing, but your ball has the downward direction being considered as positive because it's being dropped, and as it's being dropped, it's going to increase in velocity. Henceforth, this is what you're going to have. So going forward, we have, with what speed did it hit the ground the first time? So this is where you had a change in direction, right? Like that, this is where you had a change in direction. This is where you bounced for the first time. But given the fact that this is it increasing its velocity towards the downward direction, it has to reach a certain point where it's gonna reach like the surface of the ground. Now, when it reaches the ground, it's gonna get redirected at a certain velocity, at a negative velocity, and henceforth, the place where it's still positive and it hits the ground is where you're going to be having um, the speed that you are looking for. So your speed here is 8 meters per second. Why? Because this is the first time that it actually reached the ground. And they say, with what speed did it leave the ground the first time leave the ground? I've already explained that it's when you're actually now making the motion a bouncing motion because you're redirecting your motion from what it was initially in terms of direction, and henceforth you have your velocity for getting off the ground to be -4 and your speed to be 4. So I highlighted the fact that if they just said speed, you write speed. If they said velocity, you write 4 meters per second upwards. And please don't refrain from writing minus this, -4 meters per second. You don't really want to do that. Why did it suddenly get a bit brighter? The reason for that was because electricity just came back, apparently. Right, so let's move on. If the acceleration is 9.8, calculate the time to get to the ground for the first time. Alright, the time to get to the ground. You have to calculate this time right here, time to get to the ground. Now, first of all, this is a velocity time graph, right? And if you look at it, it's a linear graph, right? And it can be represented using this equation right here. And if you rewrite it, you can have acceleration sitting in this position. And this position mimics what you have in functions, what you call a straight line graph, or a line, or a linear function. And henceforth, your acceleration will have to be a gradient, right? And this is, since this is linear, it is linear, it looks linear. Henceforth, your acceleration has to be constant, and your gradient is constant, and your gradient is constant in being 9.8. And why is it positive 9.8? Because what, you have already chosen your downward direction as positive, henceforth your acceleration, which is actually downwards, so your gravitational acceleration also has to be positive. So all you have to do is just to come here, write your acceleration in the formula for M is equals to change in y over change in x, right? Now change in x is going to be, let's say, 8 minus 0. 8 minus 0 is just 8, so you write 8. And your time is going to be t minus 0. T minus 0 is just going to be t. You rewrite this, you're going to have t is equals to 8 divided by 9.8, which is 0.82 seconds, right? Now it says calculate the height, right? Calculate the height from which it was dropped. For you to be able to calculate the height, this is one thing. In the previous lecture that I gave you guys, we did explain how you could determine the certain quantities of kinematics using geometric means. So if there's a geometric shape that's formed by a particular graph, you most likely could get an answer for what you're looking for by using geometric applications. So with this one, well, by saying geometric applications, it's just another way of saying that you have to use the area under the graph. So the area under the graph from for the first time, to calculate the height from which it was actually dropped, you would actually have to look at the maximum height for the initial drop, which is this part, right? And the maximum height from which it was actually dropped will only be found in the first section, wherein you have your highest velocity being found. So how does that happen? Well, if you look at this section right here, this gives you the vibe of a what? Of a right angled triangle, right? And the formula to calculate the area of a right angled triangle is 1 over 2 multiplied by breadth times height. And continuing forward, all you have to do is just, place in your values. Here you have 1 over 2 divided by, this is, oh yeah, well, 1 over 2 multiplying 0.82 multiplying 8, and your answer is actually, let me correct this, 0.5 multiplied by 0.82 multiplied by 8. Yeah, correct actually. You have 3.27, and the height is going to be 3.27 meters. If you just use 0.82, you're actually going to get 0.28, but I used the entire answer that I had gotten from the previous one. So yeah, what if they told you to actually find displacement as opposed to finding height? Well, you're just gonna say change in y is actually equal to 3.27 meters downwards. Why is it downwards? The answer came back as positive. And besides that, you also understand the fact that when you were doing your calculations, you were doing it with the mindfulness of the fact that your ball has been dropped and the downward direction has been taken as positive, and henceforth, since it's being dropped, it's going to be moving in a downward direction. Henceforth, its displacement is in a downward direction, and downward is being considered as positive. Henceforth, you would have to say downwards. So that is actually it for our revision. We'll do revisions for other terms as well, but currently this is it, and hopefully this helps you. And one thing that I just want to emphasize before I end this, because it's so much space being taken in terms of storage and all that, but one thing that I really want to emphasize is that when people ask you, when people come and ask you questions, and you know that you have the capabilities and the time to help them and assist them with those questions, please consider doing it. Because I can tell you for sure, when you help people and when you continuously repeat a particular thing by teaching someone, it gets grounded in you as if it's now your own intrinsic knowledge, right? It's your own inbuilt knowledge, and for you to lose that knowledge is quite hard. It's like, what, you need a concussion or a dementia for that stuff to happen. So it seems like your name now. A very good example is myself when I do this. I did vertical projectile motion. Yeah, I also did it over here in university, but it wasn't like this actually. It was a bit it was looking towards x and y axis and all that stuff. But the idea is I did this stuff a while ago, right? And due to the fact that I not only had I done it a while ago at school, I was continuously helping people here where I am. If you saw my hands going like this, I was trying to hit like a mosquito. That's so wow. But yes. So yeah, please do assist other people if they ask in the groups that we have formed for you. If they ask you at school, just aim to be that helping hand. And I tell you, when that helping hand returns to you, it's going to come back to you holding tenfold more promises, tenfold more treasures than what you were willing to give. And yeah, hopefully this is very impactful to you guys, and hopefully it helps you. Right, well.